Today's lesson, our focus is going to be on irrational numbers and how we can estimate irrational numbers so that we can do a better job of comparing between rational and irrational numbers. So let's go ahead and let's look at the vocab words up top. So we've got our perfect squares that we've been talking about, and a non-perfect square just means that the number, when we take the square root, we do not have a whole number answer. So for example, square root of 36 is 6 because 6 times 6 is 36. But the square root of 37 we wouldn't be able to do because there's no number times itself that would get us 37. All right, so now let's look at perfect cubes. So perfect cubes are similar ideas. So a perfect cube would be when I take the cube root of a number, it works out to be a whole number answer or an integer answer. But if I take the cube root of a non-perfect cube, it's the same as taking the square root of a non-perfect square. All right, hopefully that helps make sense of what these vocab words are. So right now I've got the square root of 78, and I'm not for sure where the square root of 78 belongs. I'm going to put a halfway mark up here. So I am going to look at my list of perfect squares, and I'm going to ask myself, where would 78 fall? And I notice 78 is going to be somewhere between 64 and 81. So I am going to write that up here. I know it's between 64 and 81. Well, the square root of 64 is 8, and the square root of 81 is 9. So I know it's somewhere between 8 and 9. And then I just ask myself, 78, is that going to be closer to 64 or is that closer to 81? And I'm like, oh, definitely closer to 81. So I know it's going to be on the right of the halfway mark, showing it's closer to 81 than it is to 64. Okay, let's do the same sort of thing, except now we're living in the negatives. But for where we go to find it, we don't worry about the negative part yet. So right now I'm just thinking 150. And I'm going, okay, well, 150 is definitely going to be between 144 and 169. But because we're in the land of the negatives, I am going to put the 169 over here, and I'm going to put the 144 over here. And then I want to do the same thing. I want to mark the halfway point. So square root of 169 is 13, except that would be negative 13. Square root of 144 is 12, except that would be negative 12. And then I'm going to ask myself, 150, is it closer to 144 or 169? Definitely closer to 144. So I am going to put it over here on the side closer to 144, and I put in my negative square root of 150. Okay, now we're going to go in reverse. They have given us a point F, and we have to decide which one is it closest to. And I have fixed it on your notes, but there were 2 typos. Now they're fixed on the PowerPoint. Okay, so I am first just going to down here write what these things are. So the 3.3 would be closer to square root of 4. So this is close to 2. 13.7 would be closer to square root 16. So this is close to 4. 3.7 is again closer to 4. So this would be closer to 2. And 10.9 would be closest perfect square is 9. So this would be close to 3. Okay, so now I look here. I know it's somewhere between 3 and 4. So my ones that were closer to 2 are gone. And then I've got one that's closer to 4 and one that's closer to 3. So right here, I've made the selection. That would be the best representation for F. Okay, now we're going to do the same sort of thing, except we've got our points here. So I'm going to go ahead and put in, so 76 is going to be between 64 and 81. Okay? And I know then that I can eliminate A because that is between 7 and 8, and I need numbers between 8 and 9. Okay, 76 is going to be definitely closer to 81. So now I can eliminate B. And so as I'm trying to decide between C and D, well, D is almost sitting on top of 81. So I am going to guess that that's more like a number like 70, square root of 79, square root of 80. So my best guess is going to be that C is the closest representation. Okay, so now we're going to be estimating some expressions here. So these are going to involve rational and irrational numbers. The cube root of 125, well, I see right here, that's 5 cubed. So the cube root would just be 5 minus 4 times, and it says to estimate. So even though pi is this really long number, I can estimate it as 3.14, or I can even estimate it as 3. So I'm going to go ahead and just say, okay, that's close to 3. So again, I'm going to use the 2 squiggles showing this is approximately, this is an estimate. So now order of operations, I've got 5 minus 12, keep change. I've got negative 7. So that is my estimate on what it's the closest to. All right. Radical 33. Let's go ahead and find where would square root of 33 fall. Well, it's going to fall somewhere between here and here. And I am saying 33 is definitely closer to 36. So my estimate is going to be to take the square root of 36, and then the whole thing is divided by 3. Well, the square root of 36 is 6. Then we're going to divide by 3. So my best estimate here is 2. All right. Now, whenever it says to compare, they are wanting us to use either a less than symbol. So an example of less than would be like 5 is less than 9. So that's when we would use that symbol. Greater than, well, 10 is greater than negative 9. So that's when we would use that symbol. And this would be an example of 1/2 is the same as 0.5, so we would use equal to. Okay, so we have already talked about when we have the same numbers repeating, and there's 2 of them, 2, 7, 2, 7. Instead of putting 27 over 100, which means it stopped, I'm going to put 27 over 99, which means it's repeating. And then 27 over 99, both can be divisible by 9, so I get 3/11ths. I've got a 3/11ths here, I've got a 3/11ths here. Those are equal to each other. All right, cube root of 27 would be 3 times 3 times 3. So the cube root of 27 is 3. I'm going to do an estimate. 3 pi would be like 3 times 3, so it's going to be bigger than 9, but close to 9. Well, 3 is definitely smaller than 9. All right, and again, we're going to estimate here, so I'm going to call pi 3. So basically, I have 3/4. And then I'm going to say square root of 2 is like square root of 1. So basically, I'm saying, okay, I got 8. 8 divided by 4. That's close to 2. So we've got a number smaller than 1. We got a number bigger than 1, so this side is definitely going to be bigger. All right, last but not least, they might ask us to put numbers in order. And they could ask us to go from smallest to biggest, or they could ask us to go from biggest to smallest. And up top, I've put all the different words that mean smallest to biggest, and all the different words that mean biggest to smallest. Okay, so first thing you do, anytime you do this, is you kind of identify where 0 is, because you know 0 is always going to be the middle. So I've identified 0. And I know all my negatives are going to go on the left-hand side. All my positives are going to go on the right-hand side of 0. So I'm going to go ahead and just start trying to write these in things that I can quickly identify. So the negative square root of 25 would be negative 5. This is negative 3.14. Okay, so I went and found all my negatives. So right now I have negative square root of 25, and then I have negative pi. So those two are taken care of. And then I'm going to put my 0, because I know that's the middle. All right, so now I have all my positives. So let's go write the positives. Cube root of 30 is going to be a little bit bigger than 3 because 27 is the closest perfect cube to 30. Cube root of 9 is exactly, or square root of 9 is exactly 3. And then this is 5.30, and this is 5.1/3 would be 3 repeating. Okay. I've got enough here that I can organize them. So next on my list is going to be square root of 9, because that's exactly 3. Then it's going to be the cube root of 30, because that's a little bit bigger than 3 since it's bigger than 27. And then I've got 5.30, and I've got 5 1/3, which would be 3 repeating. So then that's going to be 5.3. And then last I would have 5 1/3. So then that's kind of how to tackle putting rational and irrational numbers in order. And that is the end of today's topic.